Hi, hello guys. How are you doing today? Okay, I'm back again. So what I'm gonna do today, I will be doing the EDA part two, which is mainly coding, because so far we haven't done any coding yet. So I'm gonna show you first what's exactly the agenda. I'm gonna show it to you right now. Okay, just bear with me 1 second, please. Okay, that's the agenda of today, and the agenda is gonna be EDA part two coding. And mainly we'll be dealing with all these data. Okay, you have the data here, which is in Excel files, and here you have exactly the code, right? We're not going to do all this. We're going to just cover a couple of use cases, and you'll be doing the rest of the coding by yourself. I provide you with all the output from here. Okay, so there's a data called tips. Okay, and this data called tips here, you can get it from Kaggle here. Kaggle is one of the popular websites for competition and so on when it comes to data science. And the second one is a drive, is a Google Drive. You can access all these data here, which you see the data, and the Python code, which is exactly the Anaconda Python or Anaconda Jupyter. You can access all the files that are here. You can just click on this. It's in the description part. You can click on it and you access all these information from here. Okay. So what I'm gonna do now, I'm gonna cover first the first exercise, and the first exercise is gonna be this one. Okay, and it's gonna be first of all the EDA in Python using a data called wine quality red.csv. And this wine quality.csv, you can find it in the description, in the Google Drive, okay? So let's start with it. First of all, what we're gonna do first, we're gonna do the reading of the data. That's when you have the data, the first thing to do is do the reading and have a look exactly what do the data look like exactly, okay? That's the second one. The second part is going to be analyzing the data, see exactly the missing values, what you can do with that, and so on. And part of it is going to be the checking the duplicates of the data. If there's any rows duplicated inside the data, you're going to check the outliers, you're going to check the missing values, and so on. And then the last part, you're going to do the EDA using univariate analysis, bivariate analysis. This is for one value or one feature or one target. The second one is going to be the bivariate analysis, taking two features and see exactly the correlation between them. What does it look like? And the last one is going to be the multivariate analysis. What we can do, we can start for guys. The first thing to do when you have data is first of all get all the libraries you need. And what you can do is put all the libraries at the top here. The first cell is going to be only the libraries what you can do here. You can import the pandas. You know the pandas was going to be used for. It's for the data, to bring the data and so on, the NumPy for the numerical calculation and so on. And the matplot doing some plotting. And the seaborn here, it's sitting on the top of matplot. But if you want to see something quite a sexy plot, a nice plot, I think the best way is to use the seaborn. Okay, so the seaborn is going to be used with matplot. So first thing to do, import pandas as PD. You just name here PD. The second one is import the NumPy as NP. The matplot pyplot as PLT. And the last one is going to be exactly the seaborn, which is exactly the SNS. And what you see here to import the warning is, and here, just in case you have a warning into your coding and so on, is going to display it for you. That's what it is. Okay. So the first thing to do here, the next one is to see exactly the data. Okay. So to get the data, we have to load the data. And the data we have is wine quality red.csv. And this one is sitting, in my case, it's sitting in this path, which is the D drive. D drive /data. That's a subdirectory. It's a path. For you, it can be any way you want. Okay, you can put it on the Google Drive. You can put it on your local disk. It's up to you. You can put it on the C. It's up to you. Okay, so please, if you have any question here, please let me know. Okay, so I can guide you exactly what you put your data. What is the easiest way to do it? I think to start with this, probably you can put it on your hard drive, and later on, if you get more experience, you can put it on your Google Drive. Okay, and here when you set print df, you can print df, print, or without print, doesn't matter. You can just put df.head head. Okay, you can either this way, or you can put it df.head. Okay, you can do that. Okay, let's put this one into comment. All right, you can do that, and you can see exactly the data. What you can see the data here. If you put this one in comment, it's going to be exactly the same result. Okay, you see this one is a lot sexier. It's nicer. Okay, but if you print like this, print, and you hide this to some extent, okay, you see it's a little bit tricky here, not easy to read. Probably the best way, guys, put it straight away, this one into comment, and then df.head. As you can see here, it's going to display only 5 rows. By default, when you do this, display 5 rows. Now, if I want to display more than 5 rows here, it's from 0 to 4, it's 5 rows. If you want to display more than 4, you can put 10 here, for instance. Right? And 10 is going to display exactly 10 rows. Okay? That's the first thing to know. So keep in mind, the libraries first, and load your data. When you see your data like this, at least you can have a look at them. All right? Or you can do something else too. Let's do, if you want to see the bottom, this is the top part of the data here. If you want to see the bottom part of the data, just df.tail. Okay, tail is the tail. That one is the head, the tail. Open and close brackets. As you can see here, this is the last part of the data. All right, so we have the head, we have the tail, and always it's 5. Okay, it displays only the last 5 rows here, and here the top 10 rows. It's up to you here. And you can see we have columns here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 columns. All this, what you see here, these columns from here to here, it's called the features. These are the data we're going to affect. What we would like to predict here, we have the wine. I would like to predict the quality of the wine here. Okay, so we have the features, and this one is going to affect the quality of the wine. And the quality here, it's called the target. Okay, that's the feature. We're going to use the feature to variate the feature and get the best quality of wine. Sorry. Okay, so here we have features, and we have here the target. The next part, we're going to analyze the data by doing df.shape. Okay, df is always, keep in mind, df is the data from here. That's the df. It's your data. Okay, we call them df, we call them your name, whatever, doesn't matter. Okay, so df.shape, and shape here is going to display exactly how many rows do you have and how many columns do you have. The number of rows we have here, 1599, which is this one, the last one, 19555, 199, so 1599, which is this one, plus the 0, okay, because we start from 0. So it's 1599, and this one is going to be the number of columns which are here, from here to here, to alcohol, from fixed acidity to alcohol, it's 12. So we display here the number of rows and the number of columns. The next one is going to be df data information. Let's see what sort of data do we have. Do we have categorical data? Do we have numerical data? In this case here, df info, we're lucky here, you can see only numerical data. If you see float or you see int, that's an integer data, and the float is going to be a decimal data. Take the case of quality here. Quality, all of them are integer. But the rest of the data, take the case of citric acid, is going to be float. What is the citric acid here? Anyway, citric acid is going to be float. Okay, it's a decimal data here. You have decimal data here. The same here. You have decimal data here, etc. Okay, keep this in mind. We're going to have a look now at the description of the data. Okay, the description of the data is just descriptive statistics. It's a descriptive statistics. To do that, we have seen this in the lecture, in the session last time, df.describe. When you write df.describe, it's going to display all the statistics of the data. What are they? It's going to count the number of data, 191599, which is this one, okay, which is this one, right? And it's going to have the mean of that column. That's the mean of the fixed acidity, for instance. It's 8.3. That's the standard deviation. It's a deviation from the mean. The standard deviation, it's a deviation from the mean, is 1.74. Deviation from this value. You have the minimum value of this. You have the 25%. You remember the 25% and the 75% when we have a shape curve? We have the 75% on one hand, on the right hand, the 25% on the other hand, and this one it represents 7.1. The 50% is the one in the middle where the medium is, and the maximum value of the fixed acidity is going to be 15.9. And the same is applied for all the targets and it's applied for target and apply for targets and the features. All right. So please, you can see some comments here. Have a read of that. It's very important. This one is really explaining exactly what I was doing. Okay. Now I'm going to check the columns. The names of the columns is df.columns.toList. Okay, toList here. All right. And this one is going to display for you the name of all the columns from fixed acidity to quality. It's from fixed acidity to quality. That's the name of the columns. All right, I'm showing you this so you can practice more with the next type of data. I'm gonna check the missing values. We are lucky here, we don't have any missing values. What to do, def data dot is null dot sum. Okay, the sum of the missing here, the sum of the missing values here, this column is 0. The same for the next one, etc. Here, cannot see any missing values. If you see a number here, then it is a missing value. Okay, it is a missing value. Here, we're going to check the duplicates values. Okay, these are the data which are duplicated. For instance, I'm going to see the fixed acidity. We have 96 duplicate data. Let's go back to this. Here, we can see duplicate data here. We can see 5.9 and 5.9 here. That's the duplicate data. If we can move here, we can see here 7.8, 7.8, double here, 7.4. That's duplicate data. Okay, that's what we mean here, duplicate data. Okay. Next one, we're gonna do the EDA for the now straight away for univariate analysis. Please have a read at that. Okay, and the only one thing we're gonna do the univariate analysis. We're gonna do the univariate analysis of the quality of the target itself, which is the far right left of the data, which is the quality, which is the target. Okay, and this one we're gonna see the quality of the data. We're gonna count them for each case. How many? For instance, here what it tells you here for this value. Okay, this one is probably 600. This one 600. 600. We have about for 6 quality equal to 6. We have 600 values. That's what it is. Count them. Okay. If you go back to the data here and you see, you can count for the 600 here, you're going to see exactly you have 600 values. Okay, here it's count versus the quality of the data, and the quality of the data, they vary from 3 to 8. There's no below 8 here. Okay, there's no below 8 here. Okay, oh no, sorry, all of them is below 8. There's no below 3. Okay, so that's number one. We're gonna do the kernel density plots. The kernel density plots is very important here. Please, here, probably, if you don't understand something, I know from the start it's quite threatening, guys. Okay, I'm going to explain to you how, first of all, how if you don't understand the code, second, how to deal with it. All right, this is exactly the kernel density plot. This is a sort of plots here you can generate from this code. All right, and you can see all these codes is done using the subplots. We're gonna discuss this with you, and we're gonna talk to you about here about the histogram. Okay, so the kernel density plot, it's about the subplots and the histogram. At the same time, you can see this sort of curve here, which is exactly the bell shape or the bell curve. Okay, and this one is generated using KDE. We're going to discuss with you again this. Okay, so now if you have a plot like this and you don't understand it, what you need to do, guys, is you have to cut this, copy this, or probably yes, copy this. Okay, Control C, have to copy it, and you have to go to ChatGPT. Let me stop this. Stop this, guys, and yeah, stop this, share. Okay, and you go to ChatGPT. Okay, you are with ChatGPT now. You Control V, and you have all the code. Okay, all the code. You go down a little bit, and you ask ChatGPT here, please, if you want to do nice work, get the ChatGPT 4.0 or 4.0. Okay, you can do it exactly. You can do it with different version. The free one, which is 3.5. I don't use it anymore. I'm using GPT 4.0. You have to pay $20 a month. Okay, so what you can do here, and you ask ChatGPT, please, if you don't understand the code, it's very easy. If you're very well skilled in Python, you will understand it straight away. Not straight away, but you can understand it. But I don't know you guys. So the best way here probably to get your Python up and running and getting better and better, it's very good to work with ChatGPT. And then you ask, please explain the code step by step. Okay, please explain the code step by step. And ChatGPT here is going to explain you the code step by step. Okay, so it's going to explain to you this. Okay, it's going to explain you the second one. It's going to explain you the distribution for each numerical feature. It's going to explain to you the loop here, because we have a loop because it's 4 here. Okay, and you have to read all this. Okay, step by step. You explain very easy. That's the SNS. That's a histogram. That's a subplot here, and that's the title. And they're going to explain to you this. And at the end, you have summary. Okay, this is very important, guys. Okay, and now if you don't understand something more in depth, probably you can take this one. Okay, and you can ask ChatGPT, please explain it in detail. Okay, now it has been explained already in detail here, but again, if you don't and still don't understand it, you haven't done anything before with for loop and so on, please ask ChatGPT. It will help you a lot. That's the best way. Instead of spending probably 4 or 5 months to understand Python or to code with Python, probably with the ChatGPT, you can do it in 2 weeks. Okay, and that's a good advice for yourself, guys. Okay, if I go back where I was, okay, we were here. That's the one. Now here you can see the KDE here equal true. Now sometimes the KD, you see the curve, this curve, the shape here, the curve shape. Okay. Now if you put here false, sorry, false, okay, and you run it, this one will disappear. You will have only the histogram. This curve here, the shape of the bell here, will disappear. And you run it, how to run it? Shift, enter. You see? Disappeared. All right? So here it disappeared. And now again, to understand this properly, you have the seaboard, you have the dark green of the box, and you have to read here, identify numerical values. What are the numerical values identified? Is only the one with integer and the float, which is the one we have seen before. This one, okay? And then you can plot that, or you can do, if you want only the false, I would prefer probably the true stuff here. All right, the true stuff here, you get bell shape. It's very nice here. And you can have an idea about exactly the extreme or the 25% and 75%. And you can see if you have any outliers or not. We're going to see this later on. Okay, that's exactly for the count, fixed acidity, count, volatile acidity, all the 12 data what we have here, or the 13, yeah, all the 12 data, which are the feature and the quality here at the end of the day. All right. So, and you can see the quality here at the end here. All right. All of them, all of these is the features, and this one is the quality. We're counting them, no more, no less. Okay. And we have some explanation here. Please have a read. You will understand better what's happening. We have the swarm plot. We don't use that swarm plot quite often. I never use it personally. I don't want to use it. But again, if you want to have a swarm plot, please go through this. All right, that's swarm plot. I'm not a fan of this, but I don't want to use it. The next one is going to be the bivariate analysis. Bivariate analysis, it's a pair plot. It's gonna be, to take the data here, it's gonna be this versus this versus this versus this, etc. That's called the pair plot. Okay, and the pair plot, we do it with something called the bivariate analysis. The bivariate analysis, okay, and this is exactly what sort of plot we are having. We're having this versus this one is versus this one, okay, and you can see if there's any correlation or not, etc. And here we don't see a lot of, we can see some correlation here. You can probably fit a line here. We can see some correlation here. Okay, here it's very difficult, and so forth. Okay, so this one is bivariate analysis. But if you have a smaller number of targets, then you can have this one a little bit bigger. You can plot this one a little bit bigger if you want. And this is exactly the interpretation. All right. Okay, this is exactly the interpretation. In the plot is diagonal. The plot diagonal here, what does it mean here? It's equal to 1. Okay, that's the diagonal plot here. Okay, in the plot, if the plot is diagonal, histograms of kernel density plots is shown. It shows the distribution of the individual variable. If the scatter plot is in the lower triangle, it displays the relationship between the pairs of the variables, etc., etc. Please have a read of it. Have a read of this. The violin, again, I'm not a fan of this, so I will disregard it at this stage. I'm not asking you to use it, but at least use it once to see exactly how the violin plot works. All right? Then, if you don't understand it, go back to, so here we have the violin plot here, okay, with SNS. As you can see, it's quite very attractive and quite sexy. Again, interpretation, read it, and you'll understand straight away. This is one of the most important parts, which is the box plot. The box plot here, we're gonna plot the quality, okay, and the quality of wine is between 3 and 8, or 5 or 8, whatever, and then we plot it against alcohol. So alcohol plot, quality of plot, and you can see for quality 5, you have this box plot. For this quality, you have this box plot. For 7, you have this. And what you see here, guys, outside, this is the whisker, you remember? This is the whisker. And outside the whisker, these are all the outliers. We have a lot of outliers here, from here to here. We have here a couple, here nothing, here nothing, here nothing. And here we have just only one, okay, for this quality of wine, right? And here, and this one is the median. Here, what you see here is the median. And the gap here is very small, and the gap here is quite high. This one is quite high, it's quite high and so on, but this one is very small. And the interpretation, please have a read on that, okay? And here, the same, this one, we have done it with alcohol. We have quality and alcohol, that's quality of alcohol. We do it again with quality and pH, okay? And pH is one of the column to the data, and exactly we can see some of the outliers at 6, at 5, at 4 here, okay? And all of them except the quality number 3. Now we're gonna see the multivariate analysis. We have seen the univariate, bivariate, multivariate. Again, I will recommend you guys, I would advise you to have a read here. Okay, the first thing I'm gonna do, I'm gonna see the correlation between the different variables. Okay, these are the variables, and this one is all the variables, all the features, and the target. When you do df.core, it's a correlation between all of them. As you can see, we are very focusing here on the quality. And as you can see, the quality, that's the correlation between the quality and the fixed acidity, the quality and this one, etc. As you can see here, the highest one here is what? The highest one is going to be this one, which is 0.47. So the quality is mainly affected by, mostly affected by the number of alcohol, okay? Positively, because this one is positive. And also you can see the quality is affected also by this number, minus 0.39, whether positive or negative, but negatively. If the quality is affected by the alcohol this way, which is the slope is positive, then that one, the quality is going to be affected by alcohol in a negative way. Then the slope is going to be like this, in a negative way, okay? So the main one which I see here, the quality of alcohol is, sorry, the quality of the wine is mainly affected by, first, by alcohol, and second, by the volatile acidity. And the rest are quite small, okay? The rest are quite small here, right? Now, this one, it's nice, but if I want to present this in a different way, in a very nice looking way, then we need to do something called the heat map. Okay, so the heat map is just the correlation in different way. Okay, that's the heat map here, and the heat map we incorporate within the heat map df core. Okay, that's df core here. All right, and we plot it. Now again, you can cut this and paste it into ChatGPT, and we ask ChatGPT to explain to you, especially when it comes to the format here, annotation. Annotation here is very important here. You see the true here. If I remove true into false, you're gonna see what's going to happen. Okay. So you're gonna see all the numbers disappears. Okay, all the numbers disappears. So the annotation here, keep it as true. Okay, and then you have a scale here, and as you can see here, the you can see the quality is mainly affected by alcohol here. Alcohol is yellow, which is the highest one. And the rest of them are below that. We have the pink, we have the green, etc. Okay, so all of them are below the white, the yellow. Okay, that's called the heat map. Okay, have a read at that, and this is exactly the conclusion. Have a read at that, and then I will go now to the PDF of that, of this one, and see exactly what does it look like, the PDF. So if I want to plot a PDF of, sorry, if I want to save this into PDF, I go straight away to save and export notebook as PDF. Okay, guys, I'm not going to continue with that. I'm going to show you straight away the output. Okay, and this one is the PDF. Okay. Okay, let me show you the PDF. Okay, this is the PDF, guys. Okay, we have saved your notebook into PDF. Now to open this PDF, we have to use it with Edge Microsoft Edge. Okay, Edge. Okay, Microsoft Edge to open straight with the PDF. I'm going to show you how to do it. Better to show you how to do it. Once I have this is the Jupyter. I would save it to this one, PDF. Let's wait. Yes, take some time. Yeah, okay, it has been downloaded. I go here. Now this one, I'm going to open it because it's a PDF. We cannot write on PDF unless you have the PDF editor. So we cannot. I'm going to open it with Microsoft Edge. It's a lot easier to edit your file, or you can write on your file. All right, this is the one I'm looking for. Okay, so here you can use your, if you have like a pen, okay, you can use your pen and you can go straight away what you're gonna do here. All right, so this one is, first of all, we're gonna read here. So first of all, we're gonna draw. Okay, let's do it with this. Okay, so we're gonna read this one, reading data set, analyzing data set. We have done this. Checking duplicates. We have done this. Missing values. We have done this. And then we have used the univariate analysis, bivariate analysis, and the multivariate analysis. All right. Now we have, imported the pandas. We have NumPy. We have the matplot as PLT, as NP, as PD. And we have exactly the seaborn, which is SNS. SNS is sitting on this. We have the matplot, and the top of this is sitting in the SNS. And you have the data. This is the path. Okay. And this is the data we have in CSV file. So you can put any data you want here. Okay. And you have the data to display the data into the NP stuff, NP style. Okay. NumPy Python data. All right. And then if you want to something sexier, a lot nicer, you can do it with something else. You can do it with something here. Instead, I showed you this before. Instead of print df dot, we can straight away remove this one, and remove this one, and you can have it like a pandas data frame. Okay. Now we're gonna see the df shape, number of rows, number of columns. Okay, we have the info. What sort of data do you have? The float data. These, all of them are numerical data. Okay, no categorical data here. Okay, and you can have describe. That's describe, very important here. The describe is about the statistics or descriptive statistics here. Descriptive stat, and you have the count, mean, standard deviation, the minimum, the maximum, and you have the 25%, 55%, and 50%. Okay. Next one is going to be checking the columns here. All right. That's the name of the columns here. We have the sum, how many missing value in each column, 0. The duplicate, we have seen that. This is the number of duplicates here. We explained that. And we have the univariate analysis. Okay, we have seen that. Okay, and we don't want to, the kernel density plots, we have seen that. These are the ones. You remember, guys, for the annotation here, it's going to be true or false here. Okay. This one plot, not interested. That's for you guys if you want to use it in case. You have the whole explanation here, well explained. I want you to read it. Then you move to the bivariate analysis. Okay, here we have bivariate one by one. Okay, we have all the plots here, and we have the volume plot. We don't want to use it. Okay, and we have the box plot. I explained to you these guys before. What's this? Are the outliers. And the multivariate analysis, it's all about the correlation matrix, and you put the correlation matrix here. Okay, and we have a heat map, the correlation between all the variables, including the quality, which is the target. So they have the features and versus. We are very interested in this. What are the features which influence exactly the quality? And you can see here, we have seen it, is this one, which is alcohol, positively, and this one is negatively. Okay. All right. That's number one. And we have the conclusions here. You can read the conclusion, and that's it. Okay. That's exactly exercise number one. We're going to see exercise number two. It's nearly the same concept. Now, if you understand that, this is exactly to some extent the whole EDA. Okay. The EDA is about analysis of the data. Okay. And trying to provide the data or give the data to the next phase, which is the modeling part. And that modeling part is the main thing. The modeling part is going to use exactly clean data without any issues. Okay, so next one, I'm going to show you something else. And it's going to be this sort of data. Share this one. Exactly. Okay, so this one is called the EDA profiling, investigating Titanic data. You know the story of the Titanic. Okay. Here we have the Titanic data here. Let's call it. We have few Titanic names here. We have Titanic 1, Titanic 2, Titanic whatever, Titanic without anything. So take the Titanic.csv data, and you have the Titanic 1. Take it, or Titanic clean. You have all this data into your Google Drive. You can test all of them if you want. Okay, and you have again, you have to read the data, read underscore CSV. And this data, read underscore CSV, it's going to read the CSV data. Okay? So it's going to read the passengers, the survived, the peak loss, etc., etc., etc. Okay? And we are concerned here, our problem here is to use, first of all, to spot the features which affected which affect the survived people after the disaster of the Titanic by 0 not survived, 1 survived. So this guy, he survived, and this guy did not survive. All right, and you can see the names, gender, age, sibling, and spouse, and parents and children. Okay, so your sibling and spouse, parent and children, the ticket number, the fare, how much they paid, the cabin, which the cabin is it, the unbuckled port. Okay, I'm going to plot here same data, but we're going to take the survived here on the far right hand here, because all the rest here is going to be the features, right? So we have to take the feature. We have to take the survive out of it, and we have exactly here only the we have to take the survive, which is the target, out of this, and we have to show only the features. See, we hide this column, survive. Okay. And now what you're going to do, because not all these data are useful, we don't need the name, we don't need the ticket number, we don't need the cabin number, we don't need the passenger ID, and so on. So we're going to get rid of them. We're going to make it a lot smaller. All right. And as you can see here, we remove the name here, passenger ID, ticket, cabin, unbuckled, which port. Okay. And we have a better shape of the data. We have the survived here. And this one is will be affected by the P class, by the gender, by age, by sibling, spouse, by parents and children, and by the fare. Why the fare is very important? Because they could be in first class, in the second class, in the third class, and so on. Okay, and that's why you can see there's a lot of correlation between the P class and the fare here. Okay, if we want, we can get rid of these two. Fare, we don't have to use it, so we have less features. Okay, it's up to you here. Then I will move exactly this column here to the right. All right, that's usually we do this. At least you can spot straight away what is the column which is going to be exactly the target. In this case here, this is the survived one, and the rest is going to be the features. Okay, and we describe as usual here. We describe exactly the same. Okay, to get the descriptive statistics here. Okay, and then we do the correlation. We have done this before. Okay, and shows you some of the correlation here, which is, as you can see here, is going to be equal to 1. The diagonal is going to be 1. And this one, the survived, you can see the survived is affected mainly by what? By this one, which is the P class. Okay. If you are sitting, if you have the P class number 1, you are sitting on the top, for instance, it's there's a strong chance that you survive. That's what it means here. Okay. And now we're going to do the heat map as the one before. That's a heat map. Okay, you remember here. Yes, we have the heat map here. That's 10 by 10. It's 10 by 10. The size here, 10 by 10. Okay, that's the name. Correlation heat map. That's correlation heat map. That's the font size. You can change it. All right. And here, there's something else. We're going to install it. We're going to see some profiling. Okay. We have to do pip install pandas underscore profiling. When you do that, you go through the process of profiling here. And we generate a full report. Okay, that's the generation of the full report here. So from pandas profiling, we have installed. Then we import profile report, and this profile report, we're going to show prof, which is any, you can call it anything you want, profile report here, and it's going to generate your profile report here, a full profile report. You can read it, you can have a look at it, That's overview, variables, okay? That's a correlation here, missing values, samples, duplicators, etc. Okay, or you can see this, an overview. It is displaying to you a lot of information, guys. All right. Again, guys, if you have any question on this, please, on the comment below, please tell me what sort of problem you're facing. We'll come back to you. Okay. So I might probably have a special video for that, trying to resolve all the issues you encounter. Okay. So this is very interesting stuff here. Okay. Now, after watching all this, please go to the Google Drive and try to start the ball rolling on UCM something, which is user case number, and you have all the data you want. Again, any issue, please contact me. Thank you very much, guys. Take care of yourself, and hope to see you soon.